Hey everyone, so this is part 10 of the Khan Academy All Math, but yeah, I'm supposed to go to the algebra now, but I think I may have missed something in the arithmetic section. Last thing I did was the decimals unit test. Then yeah, I got 100%, and I didn't notice the scores challenge at the bottom here again because I also missed this one. Uh, After the part where I finish this and then kind of go back again and do another video in another part. So yeah, for I guess I'm gonna do this one sports challenge before I go on to the algebra, even though it's already 42%. So I guess this 42% is like coming partially from the earlier ones. So am I recording? I don't know. Okay, cool. Okay. Oh crap. Okay, let's go. 30 questions. You've already mastered the skills, there are no more levels to reach. Yeah, I don't think I need to take this, but it's like I don't feel complete. It's so weird. I mean, one mistake, it's gonna be a really big punishment. That if I, example, make a mistake, this one, then I guess one of these guys gonna level down, depending on what topic I made mistake on, and then I will have, I guess I will have to do the quiz again, and then the unit test again. Holy shit, this is insane. Ah, crap. I can't afford to make a mistake. I think that's gonna happen. It's gonna eat a lot of time. Holy crap. If that ever happens, if one mistake and that's actually what's gonna happen, then just I don't know what to say. It's insane. Alright, so let's go. Which expression is equivalent to -6 minus 2? See? I'm pretty sure it's gonna be plus 2 and like it's -4, right? But oh crap, okay, it's not giving me like, okay, it's just for the equivalent expression. So wait, why am I pressing this? This is gonna be like -6 plus 2. Holy shit, I know this is correct answer, but I'm getting anxious because I don't want to make a mistake. Let's double check this. So it's -2, so this one's not in. Okay, that's correct. Shit, holy crap. I don't want like, sometimes I would see the question like, hey, it's easy, and then I would just I don't know. I've had those moments, and crap. Let's take time. Let's not rush things. And then let's double check. If I skip double checking and then made a mistake, then I'm gonna kill myself. I'm not gonna kill myself. Okay, wait, let me concentrate a bit. 245,384 minus 108,519. Okay. Now it's gonna have 14, it's gonna have 5, it's gonna have 7, it's gonna have 6, it's gonna have 13, it's gonna have 14, it's gonna have 3. Okay. It's gonna be 8, it's gonna be 6, it's gonna be 0, 1. 0, okay. 106865. Okay, let's double check the shit. 245. 384. 138519. Okay. 14. 5. It's going 7. We got 6. It's going 13. 14, right? Get 8. It's correct. 5. Yeah, it's correct. Oh god damn it. This is making me really paranoid, man. 0, 1, 0. This is 0 is 6. This is 0. 6, 6, 8, 6, 5. Okay, cool. Oh god damn it. Order the following values from the list to grade us. Okay, okay. Two ones, let me grade this. So this is 0.2, 0.22. 0.2, 0.22, 2 ones. Okay, cool. Sure, yeah, we're sure. Okay, complete the following equations to solve 4, 5, 6, 3 divided by 9. Holy crap, what is this? Oh, okay. 7 divided 7. Right? Okay. Let's double check stuff. Divided by 9. 500. 63 divided by 9 is 7, right? Because 8 is 8. 72. Oh crap, my heart is pounding. Holy crap. How can we rewrite 0.17 in words? That is 17 hundredths. Or 1/10 and 7 hundredths. Okay. 1/10 7 hundredths. No. 1/10 7. No. Okay, cool. Cass tried to evaluate 9 times 76 by step. Okay. We're gonna find Cass's mistake. So 9 times 70 plus 6. Okay, cool. 9 times 70 plus 9 times 6. Okay, cool. Okay, you made a mistake here, Cass. Step 3. Yeah, I'm pretty sure. Step 3, right? Step 3. Okay, sounded perfect. Which decimal is equivalent to 19/4? What is that? Oh shit, yeah. I guess I clicked outside. Okay. 19 divided by 4. 3, then... Wait, what? 1 3. 4, 16. You have 3. 30. You're gonna have like 7. 28. 2. Yo, what's this? 4.75, man. What's this overline even mean? Yo, I don't know what... Okay. I think they mean like repeating, right? So it's gonna be 4.333 unfortunately. Anyway, let's just try again. 4, 16, 3, yeah, and then become 0, get like 7, 28, and then 2, we got 20. It's gonna be 5, right? 5. Yeah. I'm pretty sure it's this one. I'm not sure what the overline means, but I'm not getting any overline on my answer. So, yeah, oh yeah. It's gonna be 0.25. Crap. That's the kind of thing I'm gonna make a mistake if I answer that fast. Okay, well, use the following to find the total number of sharks. I don't even know if I'm recording. Yeah, I'm recording. Cool. Okay. 30. Total number of sharks. Please don't be wrong. Thank you. Okay. What fraction is equivalent to point A? Holy shit, this is hard. Okay, so each jump is, I don't know, 1, 2, 3, 4. Yo, this is hard. What's this? This is 1/4. 1, 2, 3, 4. So we have 1/4 is what fraction? Oh shit! What fraction is equivalent to point A? So we're gonna have like 1 and 1/4, and then we could give this guy to that, and then we can have 5/4, right? Oh shit! We don't have that. This is insane. 10/8 is equal to it though. Yeah, let's do the process of elimination. So surely this is incorrect. This is incorrect. So 6, 4 is a possibility along with 10 over 8. But since it's a fourth and this is like a third jump, like halfway already. Let's go with 10. I'll go with that. Cool, cool. Hannah wants to use multiplication to solve to divide by 1/4. Which multiply equation can Hannah use? So we can do like the inverse thing, like so it's gonna be like 2 times 4 over 1 or just 2 times 4. Holy shit, it's not even in the question. It's not even the choices. What the hell? Yo, what is this? Holy crap, this is insane. Okay. Let's see. Uh let's see. I guess this is the same. C times 1/4. Holy crap, I can make a mistake here. 1/4 times 2. Oh, that doesn't make sense. What if I solve for C? This is going to be 8, right? It's going to be 8. If I do this, let's do this first. C, 8 times 1/4, right? So we're gonna have like this, 8 over 4, and that's equivalent to 8 divided by 4 is 2. Yo, this is insane. I'm getting paranoid. Okay, so what if we did like 1/4 times 2? We need 2 over 4. It's going to be half. It's not 8. 2 times 4. I think that's the same shit. Yeah. Crap. What is the sign of 3xy when x is greater than 0 and y is less than 0? Well, okay. This is negative, right? It's gonna be negative. Yeah. So if we have like 3 times x greater than 0, let's say 2, and then like multiplied y is less than, let's say negative 1. 6, negative 6. Y. Crap. I'm sure, but man, I don't want to make a mistake. Thank you. Okay, which point represents negative for negative? So that's gonna be 10. Yo, it's E. Oh man, this is giving me anxiety attacks. Man, Khan Academy. Oh my gosh. In which number does the digit 6 have a value that's 10 times greater as the digit in the number 6? Okay, so it's gonna be 600, right? Okay. Have a value that's 10 times as great as the digit in the number. Yeah, cool. Which point is at 13.6 on the number line? Whoa, this is hard. I'd say A, right? Because 13.6. I mean, like, surely this is greater than 2. And this is less than 1. It's exactly 2. Okay. Plot 5 over 8. This is gonna be 5. 1, 2. Oh shit, no. 1. Oh my god, crap. Why is this writing? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we're gonna graph 5, 6. 1, 2, 3, 4, 5, 6. Therefore, uh, 5/6 is greater than 5/8. Yep, that's true. There we go. Uh, let's try the big number first. 358 times 29. We have 2, 8, 45, 53, 27, 32, then we have 16, 10, 11, 9, 10, 2, 9, 3, 3, 1, then 3 decimal places, and 13. 13.392. And of course, we're gonna redo that thing. 358 times 29. Okay. Yo, I think I already made a mistake because this is 72, not 82. 72, 45, 52, 52. 27, then 32. 0 here. 16, 10, 11, 6, 7. We have 2, 8, 3, 10. 10.382. Okay, we're gonna answer it for the third time. I know it's taking time, but this is much better than doing the whole shit if I made one mistake. 8 times 9, it's gonna be 72. 7, 45. Is it really 45? Like times 8 is 40, then 9, 45, right? Okay. 45 plus 7 is gonna be 52. And then 27, 28, 29, 30, 31, 32, 16, 10, 11, 6, and 7, 2, 8, 3, 10.382, and then like 2 decimal places. Please, thank you. Cool. Okay. 1, 2, 3, 4. It's 4. I know this is 4. I know this is 4. Thank you. Subtract. It's negative 9. Negative 3 minus negative 6. No, not minus. Minus 6. Not minus negative 6. Cool. Oh shit. Okay. Oh my gosh. This doesn't even matter. See? We do the whole thing anyway, so let's do 8. 2, 3, 18. No, 11. If I add 40 into that, then I'm gonna have 126. Yo, I think I can do 9. 14 times 9. 6, 3, 9, 10. Yo, there's 12, 126. No, can't do that. It's really 8. 14 times 8. 2. Yo, is this right? Oh my god, I could be wrong. For the last time. For the last time. I'm gonna redo it again every time do I my answer. So 14 and 8, 30. 11, 12. Okay. 8, that number. 13. We got 13. Oh my god, please be correct. Thank you, thank you, thank you, thank you, thank you. The entire figure is one whole. Which multiplication equation best represents the figure? Oh crap, this is hard. Okay, so 1, 2, 3, 4, 5, 6, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna be 48. It's gonna be 48, right? But not in this sense. It's points. This is gonna be much more smaller because you're multiplying that guy less than 1, so it's gonna be much more smaller. Whoa, what is this? Let's see. It should be this one. Let's try to multiply 6, 8. We have 48. Then we have 2. 1, 2. If this is this guy, then we would have like 4. So we got 1, 3, 4. They were real small, so no. Yeah, it's D. Definitely D. 2 guys. 1, 2. Yeah, okay. Woo! Grab 8 more questions. Okay, this is taking a long time. 22 minutes in. Select the number line model that matches the expression. Oh shit, 7. Oh. What is this? None of the above, right? It's just 7. This is positive 7. The distance is in... Sure, none of this makes sense. Holy crap. No. What? Is it because it should be this one? 7 units in? Oh crap, I made a mistake. Ah, I hate it. Um, 8 minus 1. Dude, I know this is 7. This is equal to 7, but... Okay, cool, sure, whatever. I was kind of expecting like it should go like 0 to 7. Because all that 8 minus 1 is 7. So expecting a number line to be like 0 to 7. But I guess it's saying 1 and 8, and then the total distance of that is 7. Okay, multiply. Convert to 5 over 3 times 6. Now I'm losing my will to do this. 30 over... it's gonna be 10. 10, right? See, now I'm not taking time. I'm answering much more faster now. Because I've already made a mistake and I'm lost my will to live. Okay. So 2 plus 8, 2 plus 4, 6, 9, minus 6 is, oh my, I'm just going back to 3, 5. Each curvilinear represents one hole. Which of the following does the shaded area represent? Choose two answers. It's 11/10 and 1.1. Okay. Lily isn't sure how to subtract. That is the same as it. Okay. 853 minus 200 minus minus 200 minus wait, what? None of this makes sense. Yo, oh, it could be this one. 50. Yeah, it's this one. You did 200 minus 53, so you kind of flatten that shit out. And then the 30, you kind of give to this guy. So yeah. Wait, what? Yeah. Not sure. I mean, this definitely isn't enough. So yeah. The following series to one whole. Which fraction of 1/2? Fill in the blanks to solve 102 times 4. What is this? Let's do. One skill level down, so sad. And then I'm gonna redo the whole shit. I hate it. Absolute value. Negative numbers? Oh man. See? This is insane. Where is that? Oh, where is that thing? Oh good, I don't have to do this. I only have to do this one. Oh shit, unit test? No, you gotta be kidding me. You gotta be kidding me. Damn, this is insane. This is insane. Negative 25. Negative 4. Negative 8. Plus 25 minus 8. We're like 17, right? Let's see. 25 plus 21 is negative 4. Minus 4, negative 8. Negative 8 plus 25. 17, 18, 19, 20, 21, 22, 23, 24, 25. I guess that's correct. Oh man, it's insane. Where's the blue dot on the number line? 6, 9, 12, negative 12, please. 6, 9, 12. Okay. Mona is hang gliding 5/4 kilometers, 5 above sea level. Directly below her, she sees a whale 0.2 kilometers below sea level. Which of the following expression can represent distance between Mona and the whale? Yo, this is mindfuck. So let's do. Mona is here. Then the whale is here. So what if, like, we have 4 and then negative 1. So the distance obviously gonna be like 4 units, right? So if we have 3 minus -1, it's gonna be +4. Okay, so I'm confident it's gonna be correct. Okay. Which expression is equivalent to 4.25 minus 8? It's 4.25 plus 8. Just my answer. Lowest on the number left. Oh shit, confusing stuff. Still gonna be 0.6, I guess. In a board game, negative number cards. What is the sign of negative xy? Yo, what is this? Negative? Oh, okay. You're positive, right? Because x times y is gonna be negative, and then negative of that we get positive, dude. These are equal. -35. Yep. Okay, cool. Damn, I hate this. I hate this so much. That is insane. 32 minutes in. Oh shit. Sean has some candy bars that he wants to give away. He's going to give each person 1/8 of a bar and equals. Oh my god. Okay. Let's see. Sean has some candy bars that I want to give away. He's going to give each person 1/8 of a bar, and he has 2.5, 2 3/4 bars to give away. Okay, let's convert that to improper. So it's gonna be 8/11/4. And we're going to divide that by 1/8, which is the same as multiplying by 8/1. So cancel that shit. Get 4. I said 4 then. Get 2. So you have 22 as your final answer. Okay, let's do this again. Sean has some candy bars that he wants to give away. He is going to give each person 1/8 of a bar, and he has 2 3/4 bars to give away. How many people will get candy? Okay, let's go over it again. 2 times 4, 8 plus 11, 13. Not 13, 11. Over 4 times 8. Why am I multiplying this? He's going each person 1/8 of a bar. Right, so we're dividing. Okay, dude, if this is correct, this is wrong. I don't mind doing this whole section again. I guess I deserve to lose. Cool. Okay, I'm a master. Which expression matches the following number line? 1, 2, 3, 4, 5, 6. Yo, no. 1, 2, 3, 4, 5 jumps. 5 times 1, 12. And 2 answers. So 1, 2, 3, 4, 5. No. Okay. -30. What is the value of the point graph on the number line? Oh shit, this is insane. Uh, 49.49. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, cool. Which of the following numbers are equivalent to 3 hundredths? 0.03. Choose two answers. Okay, these two guys are the correct answer. Which of the following have the same value as 1.30? Okay. Two answers. No, not that one. That's not correct. 1.3. Okay, this one. 1 and 303 thousandths. Okay, cool. How about this one? Plus 3 times. Okay, cool. It's 100. Okay, cool. Which picture has an equivalent area of 1/3 shaded? This is 1/3. Uh, one answer only, right? So 1/4 and 2/3. So this is 1/3. Excuse me. You may somehow find a quotient. Okay. 0.6 divided by 2. Yo, what is this? This is 1.2, right? Oh shit, 0.3, right? Oh no, I'm not sure. Dude, this is insane. 6 divided by... What is the process again when dividing shit? We can move shit. Not really. You can do like 0.6 and then what else here? We need to do the dividing over here. So it's gonna be like 3, 6. Yo, okay. Just positive. We already done this earlier. Negative, positive is negative, and then another negative is gonna be positive. Express as a mixed number. Oh fuck. Wait, what? I say mixed number. Holy shit, how do I do that? I guess, right? Jonas split up the area of a rectangle to help him solve a division equation. What equation did Jonas solve? Okay. 540 to 92. Yo, wait, what? Division equation? No. You have remainder 4. So this is 740. Cool, okay. If we divide it by 8 or 92, either way. Let's try 8. If we do 8, this was the remainder. Yo. So, okay, let's do it. One answer. Times 9, 72, 20, 2, 16, and remainder 4. So this one's correct, yes. Yeah, feels good. This number line about to compare 2/3 and 3/4. Plot 2/3. Okay, so halfway is 3. 1, 2, 3, 4, 5, 6. This is 2/3. Plot 4/3. 1, 2, 3, 4. I don't want to make a mistake, please. Now this is certainly correct, but I'm not sure about this. This is 3 and then 6. 310. That's right. Yo, no. Okay. 310 times 4.05. The drama group has 90 minutes to practice 2 scenes. They want to practice the pirate scene 4 times. And each time takes 13 minutes. The mermaid scene takes 7 minutes. How many full times can the group practice the mermaid scene? Holy shit. What's this? Practice 2 scenes. They want to practice a pirate scene 4 times. And each time takes 13 minutes. Okay, so let's do 13 times 4. 13, right? No, 13. Pirate scene 4 times and each time takes 13 minutes. Okay. 12. 52 minutes. Then mermaid scene takes 7 minutes. So let's deduct 52 from 90. So we have 38 minutes left. Then if we divide 38 by 7. Oh shit, this is not even... Yo, this is... You even have a remainder. Do I write the remainder? Oh shit, this is insane. So again, 3 times 4, 12, 52, 90 now minus 52. So 10, 8, 8, 38. 38 divided by 7. That's gonna have 5 and 35. And then we have remainder 3. How many times can the group practice the mermaid scene? Ah, fuck. 5 times? But how about the remainder? Ah, shit. We give 5 and 3 times time. No, it's not 3 times. What if I just do 5? $5.4. What am I supposed to do with the remainder, man? Okay, let's try to solve for the remainder. So we have remainder 3. This is gonna be 4, 28, 20, we have 2, 14, 6, so we have 6 there, and then 60, 8, 6, we have 40, gonna be 5, 35, and 10. 550. This is insane. I think should be for this 5, right? Oh crap. This is making me insane. Molly tried to evaluate 93 times 5 using partial products. Find Molly's mistake. Okay. 5 times 3. Step 1 is already a mistake. Why you got 8? 5 times 3 once. Why is that 8, bitch? Or I could be wrong. See, this is how Khan Academy is turning me insane. I need to be like super cautious. Like this doesn't even make sense. It's 15 and I got 8. Okay, this is gonna be 6, 7, 8, 9, 9, 10. Oh fuck, this is hard. Okay, let's eliminate some shit. Base nut, obviously. 2 9s. Okay, this could be it. We have 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, yeah, it's remainder. And we're going to get 2/3 of that. Shit, this is hard. I could be wrong here. 6 groups of 9, 10. Oh, this is 9/10. This is also 9 too, if you think it in terms of. Oh, this is A. Less than half, more than half, more than 1. The following area model shows 6 of the burned parts. Find the area of each part. Okay. So, uh, so, uh, 3,000 for A. And then B is gonna be 420. Oh shit, 420. Then C is 100. Cool. And then D we have 14. Now we just have to add all the shit up. Okay. 300 and 3,534, right? Okay. 62 times 57. We have 14. No, 42, 43. 10, 31. We have 4, 3, 5, 3, 3, 5, 3, 4, 3, 5, 3, 3, 5, 3, 4. Cool. How can we calculate the shaded area? It's 1/4 times 3. Oh. That matches this rules. Cool. 2 is the nearest 1 when rounding. Okay, I guess this is the answer, right? The number ends in the hundredths place. This is a hundredths place. 1 when round. 2 is the nearest 1 when rounding. Sophia's battling average is 0.0 higher than Child's not battling. What's this batting? What is this? Oh, okay. Sophia's batting average is 0.22 higher than Jode's. Okay, so just gonna add those shit up. So 0.69 plus 0.020, right? So I have 11, 7, 8, 9. I'll add again, so we don't make any stupid shit mistake. Child is 169, and Sophia's is 22 higher than Child. Okay, so 0.022. We have 11, 7, 8, 9, 1, 9, 1, 0, 9. Okay, cool. Leah tried to evaluate 15 times 58 using partial products. Her work is shown below. Find the S mistake. Okay, this is already correct. Incorrect. Except, yo, 50 times 1, 10. Oh, okay, that's actually correct. Then 500. That's 110. 500. Okay, cool. 50 times 10. Then 50 times 5 once. 250. Okay, cool. It's correct. It's correct. It's correct. Oh, that's why it said 800. What the fuck? 8 times 110. It's gonna 80. 8. Yo, that's insane. $345. Oh, I feel like I did this earlier. 144,265. Subtract 345,181 minus 144,265. So 11, it's gonna be 7. We have 6, 1, 11, 4, we have 9, 0, 0, 2. Okay. 200916. 200916. Let's redo the whole shit. 3, 4, 5, 1, 8, 1, 1, 4, 4, 2, 6, 5, 3, 4, 5, 1, 8, 1, 1, 4, 4, 2, 6, 5. Okay. We're gonna get 11, and then it's gonna be 6. 7, get 1. Yo, I made a mistake earlier, right? This should be 0. No, it's not. It's not gonna be 0. Why is it gonna be 0? Stupid. It's 11 still. It's 11. 6 becomes 7. 7 minus 6. 1. So 11 minus 2, we get 9. This becomes 4. Those dice. 0. 2. 0, 0, 9, 1, 6. Let's go. 19 times 7. We get 63. We get 13. Then 2 decimal places. Let's do the whole shit. 19 times 7. 3, 6. It's 9 times 7, 63. 9 times 8 is 72. So 63. 9 times 5 is 54. And 63. Okay, cool. 7 and plus 6 and 13. Times 7, 2 decimal points, 133. Cool. 1.33. Cool. Divide, right? The quotient lowest terms. We have 12. Times 5, and then this is gonna be 5, 6, right? Gonna be 1, and then 2. So we have like 10. Yo, it's already 10. Simple. Yo, my answer's not even a fraction. Ten or 1 divided, which is the same as multiplying. This is 5 in like that, right? 5 plus 1, 6 over 5. Then we have 6 over it and 5 there. Then those two die. We got 1. Then we got 2. 1 times 1. We got 10. Oh shit, I'm not sure. George is going to plant a garden this spring. He plans to have 7 plants in each row. There will be 8 rows. 8 times 7, right? With the following number line. 1, 2, 3, 4, 5 jumps. 5 times 0.7. That's correct. 7 times 3 now. We can find 36 divided by 4 by splitting it through each row. How many rows are there? There's a rows, right? So 9. Yo, I'm gonna kill myself if this is wrong. Well, it's not. Okay. Oh shit, what is this? The 6? It's 20. 893. Yo, just to be sure, we're gonna do that manually. Like 9. Oh, it's 79. 13, 1, 7, 8, 93, right? 73, we deduct 6, we got 3. 6. Please, finally, got something cool. 4, 7. This, okay. Can't do any simplification there. Okay. 4, 5, 6, 7 over 4 is correct. So we have 35 over 4. Can we simplify this? Oh shit. Four plus 3 is 7. 35 over 4. I can't divide by 2, I can divide by 4. So this is gonna be our answer. I think this should be in proper number, okay? Let's see. We can do 8 and like a proper fraction or a mixed number. Okay, cool. So glad I didn't enter that. Otherwise, I would have made a mistake again. Over 4. We have 3 ports. This could be your answer, man. Plus 4 is 32. And 3 difference, 3 ports. My heart's pounding, but it should be correct, right? It should be correct. I mean, if this was 36, then that would be 9. Okay, cool. Just to get 500 energy points, seriously. You get like existential crisis. You get like paranoid and this all anxious. This mental battle with like making one mistake. This insane Khan Academy. Holy crap. You're gonna beat yourself up when you make one mistake. And then when you're real rabbit shithole if you lose your mind from one mistake and then it just goes like I don't know. Okay, cool. But we're done with that. We can move on. Go to algebra. Let's see. Okay, got a crown. Got a crown there. Okay. What's with the flag though? Doesn't have colors. It's supposed to be like that? Just white only? I don't know. But I don't have anything left to do here. Yo, what the? Is this different? Oh shit. So it's like I'm going like a refresher? Like every 12 hours you can do that? Nine? 60. Should I also do the master to the other one? 6. 60. Right? Okay. No change. What up? That was just a freaking refresher or something? Look, I'm missing 20 points. What the fuck? Yo, what the hell? I think that was there earlier. Let's see. Should be 100 now. Okay, cool. Where's the master 6 questions? Okay. Anyway. We're gonna go to the algebra now. Why do I have this? Let's start. Arithmetic properties. Okay. Holy shit, this is insane. It's a lot of videos, man. Holy shit. Okay, cool. Oh my gosh. Okay, cool. Let's do this. Let's do this.
Find the place
Is my mic even working? Okay, cool.
value of 3 in 4,356. Now, whenever I think about place value, and the more you do practice problems on this, it'll become a little bit of second nature. But whenever I see a problem like this, I like to expand out what
300.
4,356 really is. So let me rewrite the numbers.
The
If I were to
hundreds
write, I'll write it in different
place.
colors. So 4,356 is equal to, and just think about how I just said it. It is equal to 4,000 plus 300 plus 300 plus 50 plus 50 plus 6. And you can come up with that just based on how we said it. 4,356. Now, another way to think about this is just like saying this is 4,000s, 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 plus, or you could even think of and, so plus 300s, 300s, plus 50, you could think of it as 5 tens, plus 6. And instead of 6, we could say plus 6 ones.
Once.
Plus 6 ones. And so if we go back to the original number, 4,356, this is the same thing as 4. I'll write it down. 4. Let me see how well I can. I'll write it up right this. This is the same thing as 4,000s, 4,000s, 300s, 300s, 5 tens, 5 tens, and then 6 ones. So when they ask what is the place value of 3 in 4,356, we're concerned with this 3 right here. And its place value, it's in the hundreds place. If there was a 4 here, that would mean we're dealing with 400. If there's a 5, 500s. It's the third from the right. This is the ones place. That's 6 ones, 5 tens, 300. So the answer here is it is in the hundreds place. It is in the hundreds place.
What we're going to do in this video is think a little bit about place value tables, and sometimes they're referred to as place value charts. In previous videos, we've already talked about the idea of place value, and a place value table or a place value chart is just a way to say how much value we have in each place in a very, very clear way. So here they say use the place value chart to write 60,229. And this is the place value table or place value chart right over here. They say enter a digit, one digit number in each box of the place value chart. So really all they're saying is how many 10,000s do we have? How many thousands? How many hundreds? How many tens? And how many ones? And like always, it's always a good idea to try to have a go at it before I do it with you. So why don't you do that?
16,000, 0,000, 200s, 2 tens, and 9 ones.
Are in 60,229. How many thousands are there? How many hundreds? How many tens? And how many ones? All right, now let's do this together. So we could start at the left in the 10,000s place. This is the ones place. This is the tens place. Let me go a little bit neater. So this is ones, tens, hundreds, thousands, 10,000s. So we can see that we have 6 10,000s. So all we would do is say, we put a 6 there. We have 6 10,000s. And then how many thousands? Well, that would be one place over to the right. This is interesting. We can see very clearly we actually have 0 thousands. So 0 thousands. You might say, hey, when you say this out, you say 60,229. Don't we have 60 thousands? Well, you already accounted for that in the 6 10,000s. 6 10,000s is 60,000, but just in the thousands place, you have none. And then we move on to the hundreds place. You can see very clearly we have 2 hundreds. And then we can go to the tens place, and I've written over it a little bit, but we have 2 tens. And then last but not least, we have 9 ones. And we're done. And so the whole point of this video is to just get you comfortable with this type of format, with a place value table or a place value chart. And all it is a way of really clearly writing out how much value you have in each place in a number like this.
Right, 645,584,462 in standard form. So let's tackle this piece by piece. So the first part, we have 645 million. 645 million. So let's think about that. So we have 645, but it's not just 645. We have 645 millions. So we could view that as 645 times 1 million. 1 million is 1 followed by 6 zeros. So this piece right here is this, right over here. That is 645 million. And what is that when we write it out? If we were to multiply this out, this is equal to, it would be 645 times this 1 with 6 zeros behind it. So this would be equal to 600. I'll write it like this. This is equal to 645, and then we have our 6 zeros. 1, 2, 3, 1, 2, 3. That's just this part of the number. And I'm going to do it kind of slow and do all of the different parts of the problem. But once you get some practice, you'll find that these are a bit second nature, and you won't have to go through all of these steps. You'll just be able to write the number. Now let's move on to the next part. We have 584. Let me write that down. 500 and, actually, let me write it like this. We have, well, I'll write it like this. 584,000. 584,000. So let me write the 1,000. So 584,000. So it's 584 times 1,000. And what's that going to look at? So that's this whole part right here. So 584 times 1,000 is equal to what? Well, it's going to be 584 with 3 zeros behind it. Or you could view it as 584 times the 1, and you're going to have 3 zeros in the final answer. So it's going to be 584,000. You have our 3 zeros at the end. 584, 3 zeros. So that's that part. And then finally, we have 462. 462. And that's just 462 straight up. You can view it as 462 ones. So then you just have 462, which obviously equals just 462. Now, our number is all of these combined. It is 645,000,000 and 584,000 and 462. So one way to think about it is that you could add these three numbers. So if we were to add them, we get 645,000,000, 645,000,000, 584,000, 584,462. 462. Now, I said it'll become a little bit of second nature to you in a little bit. And the way to think about that, the easiest way to think about that is millions will have 6 zeros behind them. Thousands will have 3 zeros behind them. And just regular numbers have no zeros behind them. So what you can do when you kind of want to learn second nature, you'll just look at the 645 million. So you'll write 645, and you'll kind of keep in the back of your mind that you're going to have 6 more digits to the right of this. And then you say 584,000. So then you have your 584,000. So then you write that down. 584,000, keeping in mind that you're going to need 3 digits to the right of that. And so if they didn't tell us 462, we would just put 3 zeros here. And that would also fulfill the 6 zeros we need behind 645 million. But then they tell us 462, so we just write that right here. 462.
And we're done. Yo, why didn't you say that? It's like your trademark or something.
Write 14,897 in expanded form. So let me just rewrite the number, and I'll color code it, and that way we can keep track of our digits. So we have 14,000. So 1, yeah, I don't have to write. Well, let me write it that big. 14,897. See, I already used the blue. Maybe I should use yellow. And 97 in expanded form. So let's think about what place each of these digits are in. This right here, the 7 is in the ones place. This is in the ones place. This is in the ones place. The 9 is in the tens place. The 9 is in the tens place. This literally represents 9 tens, and we're going to see this in a second. This literally represents 7 ones. The 8 is in the hundreds place. This is in the hundreds place. The 4 is in the thousands place. It literally represents 4,000. So this is in the thousands place. And then the 1 is in the 10,000s place. Is in the 10,000s place. And you see, every time you move to the left, you move one place to the left, you're multiplying by 10. Ones place, tens place, hundreds place, thousands place, 10,000s place. Now let's think about what that really means. If this 1 is in the 10,000s place, that means that it literally represents. So this 1 literally represents. I want to do this in a way that my arrows don't get mixed up. Actually, let me start at the other end. Let me start with the 7 represents. The 7 literally represents 7 ones. 7 ones. Or another way to think about it, you could say it represents 7 times 1. All of these are equivalent. It represents 7 ones. Now let's think about the 9. That's why I'm doing it from the right, so that the arrows don't have to cross each other. So what does the 9 represent? It represents 9 tens. You could literally imagine you have 9 actual tens. You could have a 10 plus a 10 plus a 10. Do that 9 times. That's literally what it represents. 9 actual tens. 9 tens. Or you could say it's the same thing as 9 times 10. Or 90. Either way you want to think about it. So let me write all the different ways to think about it. Or 90. It represents all of these things. 9 tens, or 9 times 10, or 90. So then we have our 8. Our 8 represents, we see it's in the hundreds place. It represents 8 hundreds. 8 hundreds. Or you could view that as
8 times 100.
8 times 100.
Not 1,000.
8 times 100, or
Not 1,000.
800. That 8 literally represents 800s. 800.
Yeah.
And then the 4. I think you get the idea here. This
Yeah.
represents in the thousands place. It
Yeah.
represents 4,000s. 4,000s, which is the same thing as 4 times 1,000, which is the same thing as 4,000. 4,000 is the same thing as 4,000s added up. And then finally, we have this 1, which is sitting in the 10,000s place. So it literally represents 1 10 10,000. 10,000. 1 10,000. Or you could imagine it. You could imagine if these were kind of chips, kind of poker chips, that would represent one of the blue poker chip, and each blue poker chip represents 10,000. I don't know if that helps you or not. And 1 10,000 is the same thing as 1 times 10,000, which is the same thing as
Poker
10,000.
chips.
So when they ask us to write it in an expanded form, we could write 14,897 literally as the sum of these numbers, of kind of its components. Or we could write it as the sum of these numbers. Actually, let me write this. This top 7 times 1 is just equal to 7. So 14,897 is the same thing as 10,000, 10,000 plus 4,000 plus 4,000 plus 800, 800 plus
Color
800
coding of signs.
plus 90. That's the 90, or 90
Kind of wish
plus
he used the
90
Nutrafol
plus
for that.
7 plus 7. So you could consider this expanded form, or you could use this version of it. Or you could say this is the same thing as 1 times 10,000, depending on what people consider to be expanded form, plus 4 times
For 1,000.
1,000,
Yeah.
plus 8 times 100, 8 times 100, plus 9 times 10, plus 9 times 10,
This is
plus 7
insane.
times 1. Scroll to the right a little bit. Plus 7 times 1. So either of these could be considered expanded form.
What we're going to do in this video is get some practice writing reasonably large numbers in different ways. So for example, let's say we had this number, and I'm going to not say it out loud on purpose. So this number right over here. What I want to do is think about how would I write this out in words. And I encourage you to pause this video and try to figure that out on your own before we do it together. And actually take out paper and actually write this out. What would you,
Okay, sure,
how would you
sure.
write this number? Well, now we can do it together. And actually, before I even write it out in words, I'll write this out in a place value table because it might help us, or it just helps us break down exactly what this number represents. So just as a bit of a refresher, if you're not familiar with place value tables, you think of a column for the different place values. And here we're going from the ones place all the way to the tens, hundreds, thousands, 10,000s. So we're going to have a 10,000s place right over here. We're going to have a thousands place right over here. And this is just an S here. So 10,000s, 1,000s. Sometimes you'll see it written out. This is the hundreds place. This is the tens place. And this is the ones place. And so how many 10,000s do we have? Actually, let's start at the ones place. How many ones do we have? We see it right there. We have 5 ones. How many tens do we have? We see it right there. Actually, we have 0 tens. How many hundreds do we have? We see it right there. 6 hundreds. How many thousands? We'll go to the thousands place, and we see we have 2 thousands. And then how many 10,000s we have? Well, we see right there. We have 8 10,000s.
Oh shit, 8.
So now that we have this representation, let's write it out in words. And you don't have to do this every time, but I'm just trying to make sure we see every possible way of thinking about it. So you could say 8 tens, 2 thousands, 6 hundreds, and 5 ones, but that's not exactly how people would say it out in words. What is typical is that people would say 82,605. And so I'm going to write it that way. And when you write out in words, the standard way of doing it is actually put commas wherever you would put the commas in. This is right over here written in standard form. So what we would do is we would express this part right over here as 82,000. So let me write it out. 82,000, and then put this comma there. 82,000.
Oh, wow,
comma.
cool. I put a
And then
comma
we
as well.
have
Cool. Wow.
600, and then we have no tens, so it's 605. If there was a 110 here, then it would have been 615. This is just 605.
Yeah.
So I will do it in a different color. Let's do it in this blue color. So 82,000, and then 600. 605. And we're done. Let's do another example. So now I'm going to write out a number in words, and I want you to write it in standard form. So the number is
All right, cool.
50,000.
50,000.
600.
600.
31.
Oh, wait, done.
30.
50,631.
And I want you to write this in standard
Come on, Sal.
form. So it's really just write it out as a number and put commas in the appropriate places. Pause this video and see if you can do that. All right, now let's do it together. So this first part, 50,000, well, we could just write that as, actually, let's put the place values out here. So this is a 10,000s place, this is thousands place, hundreds, tens, and ones. So 50,000. So 50,000s you could write like this. You could say that's 5 10,000s, or you could say this is 50,000s. Then they say 631. So 600, well, that's 600s right over here. And then 31, that is 30 and 1, or 3 tens and 1 1. 1 1, or 31.
Sure.
And of course, you want to put your comma in the same place. And you put your comma every 3 places. So the first time you do it, if you're moving from the right, you put it between the hundreds and the thousands place. So there you have it. This is the same thing as
50,631.
and 31.
And
This is
31.
that number written in standard form.
50,631. Cool.
We have the number 43,249.
249.
What I want you to think about is what these two fours actually represent, and how much more value is represented by this first four, this 4 on the left, than this 4 on the right. And I encourage you to pause this video and think about that. So let's just think about what each of these digits represent. So the 9 is in the ones place, so it literally represents 9 ones.
Yo, my eyes are giving up on
This
me.
4 on the right, I should say, is in the tens place. So it literally represents 4 tens, or 4 times 10, or 40. This 2 is in the hundreds place.
Giving up.
So it literally represents 2 hundreds, or 200. This 3 is in the thousands place. So it represents 3 thousands. And then the 4 on the left is in the 10,000s place. 10,000s place. So it literally represents 4 times 10,000, or 4 10,000s, or 40,000. So let's actually compare the value that we're getting here versus here. So what's the difference between 40,000 and 40? Well, 40,000 has 4 zeros, while 40 only has 1. So if you wanted to go from 40 to 40,000, you would have to add 3 more zeros, and we already know how to do that. You could add 3 more zeros by multiplying by 1,000. So 40,000 is equal to 1,000 times 40, or we could say the 4 on the left here, this blue circled 4, represents the blue circled 4 represents 1,000 times the value as the yellow circled 4. Now, another way of thinking about it is every time you move place values to the left, as you see here, this is tens, hundreds, thousands, 10,000s, you're increasing what those place values represent by a factor of 10. So if you're going from this 4 to this 4, times 10, times 10, times 10. You multiply by 10 the place value, and you see that with the place values right over here. The place values increase by a factor of 10 each time. So if you're going from this place to this place and you have the exact same digit there, multiplying by 10 3 times is the same thing as multiplying by 1,000. So whatever this represents, multiply it by 1,000, and you're going to get what this represents.
Yeah. Cool.
The 4 in the number 5,634 is blank times blank than the 4 in the number 12,700.
Oh, okay. It's 10 times greater.
So the 4 in the number 5,634, that's literally in the ones place. It literally just represents 4. Now, the 4 in the number 12,749, that 4 is in the tens place. It represents 40. So this 4 represents 10 times, it's a 10 times smaller value than this 4. This only represents, or this 4.
Oh shit, I got it
this
the
4
other way
here
around.
represents 4, while
It's
this
10 times less.
represents 40. So it is 10 times smaller than the 4 in 12,749. 4 by itself is 10 times smaller than 40. Make sure I got the right answer. Let's do another one. The number 3,779,264, or in the number 3,779,264, how many times less is the second value of
the value of the second 7
than the value of the first 7? How many times less is the value
10
of the
times
second
less.
7 than the value of the first 7? So the second 7 right over here, that's in the 10,000s place. It literally represents 70,000, 10,000 or 70,000, while this represents 700,000 or 700,000. So the second 7 is 1/10 the value of the first 7. Or another way of thinking, it's 10 times less. This is 70,000 and this is 700,000. So the value of the second 7 is 10 times less than the value of the first 7. Let's do one more. This is fun. Fill in the following blanks to complete the relationships between 25,430 and 2,543. All right. So 25,430 is 10 times, well, it's 10 times larger than 2,543.
10 times larger.
You take this, you multiply it by 10, you're going to get
25,430.
The digits in 25,430 are one place to the blank of the digits in the number 2,000.
Are one place to the left.
Well, let's think about it. Here you have a 2 in the thousands place. Here you have that 2 in the 10,000s place. Here you have a 5 in the hundreds place. Here you have a 5 in the thousands place. And we could keep going. What we see is the corresponding digit. It is in 25,430.
One place to the left.
They're one place to the left of the digits right over here. Now finally, we're going to take 25,430 and divide it by 2,543. Well, we already know that this first number is 10 times larger than this number right over here. So literally, if you were to divide the smaller number or if you were to
the
divide
larger
the smaller
number by
into the larger one, you're going to get 10. This right over here is 10 times larger than this. We said that was the first part of the question. And we are done.
Cool, we're done. Whew, this is insane. This video, each video is like 750 energy points, and then the course challenge is 500 points. Dude, that's insane.
Hundreds times 10. Well, let's focus first on this times 10 part of our expression, because multiplying by 10 has some patterns in math that we can use to help us
we've been through
solve.
this.
One pattern we can think of when we multiply by 10 is if we take a whole number and multiply it by 10, we'll simply add a 0 to the end of our whole number. So for example, if we have a whole number like 9 and we multiply by 10, our solution will be a 9 with 1 0 at the end, or 90. Because 9 times 10 is the same as 9 tens, and 9 tens is 90. So let's use that pattern first to try to solve. Here we have 7 hundreds, so 7 times we have 100, or 700. And we're multiplying again times 10. Use this pattern over here, our solution will add a 0 at the end. So if we had 710 times, we would have 700 with a 0 on the end, or 7,000. So 7 hundredths times 10 is equal to 7,000. But there's another pattern we could use here. another pattern to think about when we multiply by 10, and that is that when we multiply by 10, we move every digit one place
To
value.
the left.
One place value left, or one place value greater. So let's look at that one on a place value chart. Here we have a place value chart. To use that earlier example when we had 9 ones and we multiplied it by 10, our 9 moved one place value to the left. It moved up to the tens. Now we had 9 tens. And we filled in a 0 here because there were no ones left. There were 0 ones left. And so we saw that 9 times 10 was equal to 90. So again, it's the same as adding a 0 at the end, but we're looking at it another way. We're looking at it in terms of place value, and multiplying by 10 moved every digit one place value to the left. So if we do that with this same question, 700s, if we move hundreds one place value to the left, we'll end up with thousands. So 700 times 10 is 7 thousands. Or as we saw earlier, 7,000. So either one of these is a correct answer. 700 times 10 is 7,000. And here's an example with division. Now we have dividing by 10.
Little place value
And as
to
you
the
might
right.
predict, dividing by 10 is the opposite of multiplying by 10. So our patterns are also the opposite. Instead of adding a 0 to the end of a whole number, we would drop a 0 at the end. We would drop a 0 at the end. So for an example, if we had 40 divided by 10, we would drop that 0 and end up with 4. If you divide 40 into groups of 10, you have 4 groups.
That's true.
Let's use that over here. 210.
No, you don't
or
have
212
0.
tens. So we have 212 tens. So
Oh,
212
tens, okay.
10 times. That's how we got the 0 there.
What if 200?
And we
12
divide that
ones
by
divided
10.
by 10.
We can use this first pattern we thought of and just drop the 0 on the end. Let's drop that 0, and our answer will be 212. But we could use the place value pattern. We could think in terms of place value, and instead of moving one place value to the left, one place value larger, we're going to move one place value smaller. Or to the right.
Smaller.
One place value to the right.
Or to the right.
So what's one place value smaller than 212 tens? If we have 212 tens divided by 10, we want to move this tens one place value to the right or smaller, which is ones. So our solution would be 212 ones, which is equal to what we already saw, simply 212. So 212 tens divided by 10, we could write the number out and drop a 0, or we could think about place value and move one place value to the right. Either way, our answer is 212 ones.
We have 4,500 equals 3,000s plus how many hundreds? Question mark hundreds. So let's write this left-hand side. So I'm going to write it out in terms of thousands and hundreds.
150 hundreds.
This is equal to 4,000s, which is the same thing as just 4,000.
Oh, plus, okay.
500.
This will be 100 and
You could also use 500.
15.
Plus 500. So this is
150
the left-hand
hundreds.
side. Now let's look at the right-hand
Or
side.
1500?
We have 3,000s.
Just 1500s.
So it's 3.
Just 1500s over the
3,000s.
5.
Now let's not even look at this right now. Let's just think about
Even
what do we have to add to this right-hand side in
4,500.
order to get the same thing that we have on the left-hand side. Well, if you compare the 3,000 and the 4,000, you see you have an extra 1,000 over here. So let's add an
Doing
extra
math
1,000
before
on
I
the
say
right.
it.
So we're going to add one extra 1,000. And now we just have 3,000 plus 1,000. This makes it the 4,000. But then, of course, we also need another 500. So we're going to need plus a 500 right over here. So in order for these two things to be equal, we need to say 4,000 4,000 plus 500 plus 500 is equal to 3,000 plus 1,500 plus 1,500. Now, the way they've set this up, we need to express, so it almost looks the same. On the left-hand side, this is 4,500, so this right over here, this is the same thing as 4,500. This is this right over here. And on the right-hand side, we have 3,000s, so that's this right over here. That's the 3,000s. And then we just need to express this as hundreds. So 1,500, this is the same thing as 15 hundreds. So let's rewrite everything. We can rewrite this as saying 4,500, just to get the exact same form that they wrote it over there. So we could write 4,500 is equal to 3,000s plus, now we have to just write this in terms of hundreds. Well, this is 15 hundreds. Literally, if you took 15 times 100, it's going to be equal to 1,500. So this could be viewed as 15 hundreds. So plus 15 hundreds. So in this situation, the question mark is equal to 15.
Wait, what?
This is 15 hundreds. Literally, if you took 15 times 100, it's going to be equal to 1,500 plus 15 hundreds.
I'm gonna rewatch the whole thing, even though I know it's easy. I wasn't
We
paying
have
attention.
4,500 equals
My mind was kind of
3,000s
wandering
plus how
somewhere
many
else.
hundreds? Question mark hundreds. So let's write this left-hand side, but I'm going to write it out in terms of thousands and hundreds. So I'll write the thousands in orange. So this is equal to 4,000s, which is the same thing as just 4,000, plus 500, which you could also view as 500s, plus 500. So this is the left-hand side. Now let's look at the right-hand side. We have 3,000s, so it's 3,000s. Now let's not even look at this right now. Let's just think about what do we have to add to this right-hand side in order to get the same thing that we have on the left-hand side. Well, if you compare the 3,000 and the 4,000, you see you have an extra 1,000 over here. So let's add an extra 1,000 on the right. So we're going to add one extra 1,000. And now we just have 3,000 plus 1,000. This makes it the 4,000. But then, of course, we also need another 500. So we're going to need plus a 500 right over here. So in order for these two things to be equal, we need to say 4,000 plus 500 is equal to 3,000 plus 1,500. Now, the way they've set this up, we need to express, so it almost looks the same. On the left-hand side, this is 4,500. So this right over here, this is the same thing as 4,500. This is this right over here. And on the right-hand side, we have 3,000s. So that's this right over here. That's the 3,000s. And then we just need to express this as hundreds. So 1,500, this is the same thing as 15 hundreds. So let's rewrite everything. We can rewrite this as saying 4,500, just to get the exact same form that they wrote it over there. So we could write 4,500 is equal to 3,000s plus, now we have to just write this in terms of hundreds. Well, this is 15 hundreds. Literally, if you took 15 times 100, it's going to be equal to 1,500. So this could be viewed as 15 hundreds. So plus 15 hundreds. So in this situation, the question mark is equal to 15. Compare the expressions on both sides of the question mark. So on the left-hand side of the question mark, I have 7,907. So it's 7,000 plus 900
Oops, excuse me.
plus 7, which is going to be the same thing as 7,970.
970.
Now let's compare that to what we have on the right-hand side of the question mark. On the right-hand side,
7,907
7,970, which is 7,970. Or we could, if we wanted to expand it out, we could write that as 7,000 plus 900 plus 70, and then we have 0 ones. So if we compare place value by place value, we have 7,000 in either case, so the thousands place is the same. We have the same number of hundreds, we have 9 hundreds. But here we have no tens, and we have a 7, and here we have no ones, and we have 70.
Oh.
And clearly 70 is greater than
Okay, I
7.
see.
So the number on the right is greater than the number on the left,
thought
but the
the
number
question
on the
was, like,
left is
questioning-
less than
Okay, cool.
the number on the right. I always remember the less than symbol because it points to the
smaller
smaller
number.
number, or either of these symbols point to the smaller number. So this right over here would mean greater than. You have the larger number on the left. This is less than. You have the smaller number on the left. So we would go with less than. This is less than that.
5 thousandths equals how many hundreds? There's probably a few ways we could take this on, but maybe let's start by thinking about these 5 thousandths. 5 thousandths is 1,000 5 times. So let's think about each of those thousands, each of those 5 thousandths. In 1,000, how many hundreds are in 1,000? 1,000 equals how many hundreds? Well, let's see. Let's count by hundreds until we get to 1,000. And I'll keep a little tally mark so we can keep count of how many hundreds it takes us to get to 1,000. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So it took 10 hundreds to get to 1,000. So 1,000 is 10 hundreds. So what would 5,000 be? Well, 5,000 is 5 times as many thousands. So we're also going to have 5 times as many hundreds. So 5 thousandths will equal 5 times 10 hundreds. Because we have 5,000 this time, so we have 5 times 10 hundreds. Or 5 times 10 is 50. So 5,000 equals 50 hundreds. Another way we could think about this is place value. So let's do that. Let's look at a place value chart. Here we have a place value chart, and if we fill in 5 under thousands, we can see that we have 3 empty spaces. We
Oh
have
my
no
gosh, Mirror
hundreds,
sucks. Yeah.
no tens, and no ones. So we need to fill those in with zeros, or 5,000. Again, it's 5,000. Writing the word thousands essentially replaced those 3 zeros. 5 thousandths is the same as 5 with 3 zeros behind it. And now we want to change these 5 thousandths to be hundreds. Well, when we read this place value chart, when we read 5, when we stopped here, 5 is the last number we read, and then we read the place value above it, thousandths. So for hundreds, we'll do the same thing up until the hundreds. We'll read the place value chart until the place value we want, and then the place value. So 5 thousandths is the same as 50 hundreds. 5,000 is equal to 50 hundreds.
Wow.
And we don't have to include these last zeros on the end, because just like thousands implied 3 zeros, hundreds, by saying hundreds, we've essentially implied that these 2 zeros are there. So 5 thousandths is equal to 50 hundreds. We weren't asked about tens, but we could look here and figure it out, I bet. Tens, we would say, is 500 tens. We'd read up through the tens and then the tens place, because tens have 1 0 after them. That 0 is implied when you say 10. And then finally, if we went all the way to the end, we could also say that this number is equal to 5,000 ones. So any of those, 5 thousandths, 50 hundreds, 500 tens, or 5,000 ones are equivalent. They're all equal to each other. But the one we were asked about was hundreds, so 5 thousandths equals 50 hundreds. Here's another one. 30 tens equals how many hundreds? So this
3
time we're
hundreds,
looking at tens
which is
and
smaller.
hundreds.
Yeah, cool.
So let's think about how tens and hundreds relate. How many tens are in 100? How many tens are in 100? And we could write 100, the word or the number, in 100.
Yo, you should have done.
Well, to figure that
How
out, if we
many
don't know already, we
110
can
are
count
there
tens.
in
We can
100?
count by tens and see how many tens it takes us to get to 100.
That would have been interesting.
110 is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we got to 100 and it took us 10 tens. There are 10 tens in 100. So if there's 10 tens in 100, how many hundreds are in 30 tens? Well, to get from 10 tens to 30 tens, that's 3 times as many tens. So we'll also have 3 times as many hundreds, or 3 hundreds. 30 tens is 3 sets of 10 tens. 10 tens are 100. So another way to think of that is 30 tens is 3 sets of hundreds, or 3 hundreds. We could also think about this in terms of place value. Here we have this tens, and we know that tens can be represented by a 0. So instead of 30 tens, we could simply write a 30 with a 0 on the end. That's 0 for tens. And then over here, equal to, we have hundreds,
Zeros.
and hundreds can be represented by 2 zeros. So to make these equivalent, what number will need to fill in this spot?
It's gonna
And
be
the answer
3.
again is a 3, like we already saw
So on the top, yeah.
So 30 tens is equal to 300.
And we're done. Painfully slow videos.
What is 19 thousands plus 7 tens? First, let's think about what are 19 thousands and what are 7 tens, and then from there we can add them. So 19 thousands would quite literally be if we had 1,000 19 times. So there's 1,000 one time. If we had 1,000 two times, we would have 2,000. If we had 1,000 three times, we would have 1,000, 2,000, 3,000. And the pattern here should be pretty clear. If we had 19 thousands or 1,000 19 times, we would have 19,000. So 19 thousands is literally 19 thousands. And then 7 tens, same thing. We could have 7 tens. We could have tens 7 times. So 10 plus another 10 plus another 10. And this one's a little simpler to do than the 19. We only have to list 7 tens this time. That's 6 tens, and there's 7 tens. So 7 tens would be literally 7 tens. Or 10, 20, 30, 40, 50, 60, 70. So 7 tens is 70. And then if we wanted to combine these or add these, we would have 19 thousands,
And 7.
0 hundreds,
7.
the 7 tens, and 0 ones, or 19,070. We could have also thought about that question in terms of place value. Instead of listing out all the thousands and listing out all the tens, we could have thought of the place values. We had 19 thousands, which means we want our last digit, the 9, to be in the thousands place value. And then the other digit, we had 1, would go in front of it. So this is read 19 thousands. And by writing that thousands there, we covered all these empty place values, or the 3 zeros we ended up adding. The thousands can be represented by these 3 zeros at the end. Whereas 7 tens, we put a 7 in the tens place. And again, we have an empty place value behind it. We had no ones with it. The tens, by saying tens, we implied this 0 after it. So the thousands added these 3 zeros to the end, and 7 tens added 1 0 to the end. And again, if we combined them, like we saw on the previous one, we'd have 19,000, 0 hundreds, and 7 tens. So either way, whether we list out what 19 thousands is literally with 19 thousands, or 7 tens literally, 10 7 times, or we look at it in terms of place value and add the zeros on the end, either way our solution will be 19,070. Here's one more. We have 5 10,000s plus 22 thousands. So two ways again we could try to solve this. One, we could think about what are 5 10,000s. If we had 10,000 5 times, another 10,000, another, that's 3, 4 10,000s, and 5 10,000s, that would be a total of 50,000.
Or
10,000,
5
20, 30,
10,000s.
40, 50,000. So 5 10,000s is 50,000.
50,000.
50,000 plus 22,000.
So
22,000. Remember when we did the 19,000s, if we wrote 1,000, it would be 1,000. If we wrote 1,000 2 times, it would be 2,000s. If we wrote it 22 times, then it would be 22,000s. There would be 22,000s.
Yo, come on.
And we could combine
Okay.
these numbers. 50,000 plus 22,000 will be a total of 72,000. So one way there, that first way we talked about, is to think about what does 5 10,000s look like and what do 22,000s look like to get our numbers and then add them. Or the other way we could solve this is with a place value chart, is thinking about place value. So let's put a place value chart in here and then put our first number, which was 5 10,000s. So we have 5 in the 10,000s place, 5 10,000s. We can fill in the zeros behind it in these empty place values. There were no thousands, hundreds, tens, or ones. So for 10,000s, we added 4 zeros behind it. And the other number was 22,000, so 22. We read this as 22,000, always saying the place value of the last non-zero digit we see. So 22 and then 1,000. And then with thousands, like before, we'll add 3 zeros to the end. And finally, when we combine these numbers, when we look at the place values, we now have 7 10,000s.
There's no regrouping happening
Two
here.
thousands, still no hundreds, no tens, and
So I
no
guess there's
ones.
gonna be a video about that.
So our solution for 5
And
10,000s
it's gonna be, I guess, much more slower than this one.
is 72,000.
This is insanely slow. Next article. The number place chart. Okay. There's values. Okay. Yeah. Okay. Whole number place value. In a whole number, the digit part of it is also plus place. Next part is tens, remaining difference between the digits left. 4. The 400s, 5 times 7. That's right. Check far. No, the farther the digits still left, the greater its place value for. Because there's, yeah. What's the place value? 8 hundreds. 1 10,000. Which is create the lowest possible 4-digit number. Okay, let's get smallest possible. There we go. Wait, what? No. What value does 5 represent in 10? What value? 1,000, right? Or let's say like this. Kidding me? Okay. One try problem like this. Yo, I'm getting sleepy and all. So wait right now by adding value of digits. We can just place chart thing of value of numbers digits. Let's try saying in expand form. Cool. Which expression is equivalent to 200 is 10,704. It's in standard form. Wait, what? To write in standard form? Oh, okay. What is this holding number when you add 4 tenths? 3866. Cool. Okay, last article. Written form is a way to write now using only words. 7,000s, 200s, 10 tenths, and 1 ones. In written form is 7,229. Okay. What is 50,631? Okay, cool. 3,079. To write 892. 892. Okay, cool. Match the written form and expanded. Okay. 4,000, 40,000, and 4,000. Okay, cool. Finally we get the practices. Damn, it's insane. Place value tables, okay. Enter a one-digit number in each box of okay. 8, 7, 4, 3. No. We don't have this. We only have 8, 7, 4, 4. Yo, what the? 4, 3, 5. Which of the following place value table shows 15,690? Fitness, 15,690. 4, 2, 1, 10. 0 ones. Which of the following place shows 277 thousands 451? Cool. Proficient master in expanded form. 508. This the 7, 6 ones. What is in standard form? 700,067. Which expression is equivalent to 7,000? 229. Yeah, this one. 9,000s, 800s, 501s. So 9,850. What is 10,000 standard form? Okay. 12,005. Which expression is equal to 18,000 plus 8 plus 9? Okay, cool. Oh my gosh, another round of videos. And I don't even have to do the practices, man. Straight to quiz after all the videos. Okay, maybe I should just do all those videos and then do the quiz. And then tomorrow I could do all. Holy shit, it's a lot. And a lot of video watching is gonna happen.
In this video, we're going to be doing some rounding, which you're probably not familiar with just yet.
Yo, I'm familiar with it.
Straightforward, and we're going
You've
to start
already taught
by
me to do the rounding
to
back in the
nearest
arithmetic
10.
section.
So the first question is, what is rounding and why is it even useful? Well, let's say that you have the number 37. It's a fine number, but let's say that you have to do some math with the number 37, and you can do a lot of math with the number 37. But let's say you just want to estimate what something might be. Let's say that someone says, hey, I have 37 pickles, and you have 39 pickles. Roughly, how many do we have together? We don't have to have it down to the exact number of pickles. Well, then rounding will actually be a very useful tool. But let's just focus on what it means to round to the nearest 10. So when they're talking about rounding to the nearest 10, we're going to be thinking about the tens place of the number. So we can see right over here in our tens place we have a 3. And so that 3 represents 3 tens. So the number 37, it's 3 tens and 7 ones. So it is more than 3 tens, and it's going to be less than 4 tens. So this number is going to be more than 3 tens. I could do it like this. It's going to be more than 3 tens, which we can represent like that. 3 tens, 0 ones, or you might know that as 30. And it's going to be less than 4 tens, or also known as 40. And so when you're rounding, you're either going to round to the number of tens that is right below this number, or the number of tens that is right above that. But how do we know whether 37 rounded to the nearest 10 is going to be 30 or 40? Well, to answer that question, let's first just do it visually on a number.
Holy shit, does
And
this
then
really need to have
we can come up with some
maybe 8
rules for
minutes?
ourselves. And so first of all, let's just count by tens and make sure we include 30 and 40. So if we start at 0, 10, 20. Actually, let me have a little bit
This is
more space.
insane. Rounding to nearest 10 in like 8 minutes or so.
10, 20,
I could
30,
cook a freaking noodles
40.
twice.
That's enough, but I can just go to 50. Just complete this.
Instant ramen.
And so, where is 37 on this number line? Well, it's between 30 and 40. And if I wanted to make it a little bit clearer, if I said that this is 35 right over there, right in between 30 and 40, then 37 is going to be right about here. So that is 37. And so when you're rounding to the nearest 10, and remember we're picking between 3 tens and 4 tens, you say which 10 is it closest to? Is it closer to 3 tens or is it closer to 4 tens? Well, you can just look at this and say, hey, it looks a lot closer to 4 tens. And so in this situation, 37 rounded to the nearest 10 is going to be 40. And so you might ask a question, well, give me another number. What if someone said 32 rounded to the nearest 10? Well, 32 is going to be right over here. And then you'd say, all right, well, that's between 3 tens and 4 tens, but it's a lot closer to 3 tens. So 32 rounded to the nearest 10 is going to be 30. Now, an interesting question that you might be wondering is, what if you're right in between? What if we wanted around 35 to the nearest 10? 35, once again, it's between 3 tens and 4 tens, between 30 and 40. Which one do we round to if we want to round to the nearest 10? Well,
the rule of thumb
is, and this is really just something that the society has decided on, is that if you're right in the middle, you round up. So the number 35 is going to round up to 40. Even though it's exactly 5 away from each of these numbers, 35, if you're right in between, is going to round up to 40. If you're a little bit less than 35, then you're going to round down to 30. But with that out of the way, let's do some more examples. Let's do an example of a 3-digit number where we're rounding to the nearest 10. Let's say that we want to round the number 124 to the nearest 10. Well, there's a couple of ways that you could think about this. You could say that this is 100, 2 tens, and 4 ones. Or you could even view this as 12 tens and 4 ones. So you could say, hey, this is in between 12 tens and 4 ones. It's greater than 12 tens, which is 120, and it's less than 13 tens, which is 130. These are the 2 tens that are closest to this number. And then to decide which one it rounds to, you might already be able to think about it based on some of the rules we came up with, but let me draw it on a number line for you.
Draw it on a number line for you.
We have to get all the way to 130. So let's just start. I'll start at 100. So this is 100, 110. We draw the number line. We're going to have 120. Then we go to 130. I'll just do 140 here just for filling out the number line that I've drawn so far. And then I'll draw the halfway mark, which is 125. And then, let's see, it's halfway, so maybe a little bit closer to there. And then 124, I'm doing this red color. 124 is right over there. 124. And so if we're trying to pick between 120 and 130, between 12 tens and 13 tens, which one is it closer to? Well, we can see it's only 4 away from 120, while it's 6 away from 130. So we would round down. We're going to round down to 120 in this situation if we're rounding to the nearest 10. If this was 125, or 126, or 127, 128, or 129, well, then we would round to 130. And of course, if it was 130, we would round it to 130. Let's do one more example. And actually, I'm going to do a 1-digit number. Let's say we want to round 7 to the nearest 10. I'll write it out. Round 7 to the nearest 10. Pause this video and see if you can do that.
Just going to be 10.
All right.
And if
Well,
you round 7 to
seven
the
is
nearest
between what two
1,
tens?
it's going to be 10 as well,
Well,
isn't it?
7 is less than 110. So it's less than 110. And it's greater than 0 tens. So it's between 0 tens, which is just 0, and 110, which is 10. But which one does it round to? Well, here, once again, we can draw our number line. So we'll do 0, and then
What?
this is 5, and then this is 10, and 7 is right about there. That is where 7 is. And we can either visually see that 7 is closer to 10 than it is to 0. It's only 3 away from 10, while it's 7 away from 0. So you would round up to 10. Or you can use the rule that we just thought about. 7 is greater than or equal to 5. So you round up. You round to the 10 that is higher than this number. If this number was, if in the ones place, I can say, if your ones place is between 0, it's greater than or equal to 0, but less than 5, then you round down. And you can see that happens in all of these situations. If you looked at 37, you look at the ones place, and your ones place here is greater than or equal to 5, so you round up. Here, if your ones place, it's greater than or equal to 5. It's 5 exactly in that situation, so it's equal to 5. Once again, you round up. If your ones place is
So less than 5.
well, in this situation, we round down.
30.
If your ones place
30.
is less than 5,
20.
you round down. Your ones place, and here you only have a ones place, but it's greater than or equal to 5, we rounded up.
It's pretty sick.
Round 1,585 to the nearest tens. Let me rewrite the number. 1,585 to the nearest 10. So we want to focus on the tens place. We want to focus on the tens place. If we were to round it up, we would go to 1,500. Actually, let me color code it. We would round up to 1,590. The 8 would round up to a 9. And 90, if we were to round down, we would go to 1,500, and we would round down to 80. So these are our two choices. Now we've seen the last few examples. If the place to the right of it is 5 or greater, if it is 5 or greater, we round up. Well, the place to the right of it is definitely 5 or greater. It is 5. So we round up. So it is 1,590. And we're done.
Cool.
At this point, you are likely already familiar with the idea of rounding. Probably you have had some practice rounding to the nearest 10. Now we're going to do another type of rounding. We are now going to round to the nearest 100. So let's just start with an example. And you'll see that in a lot of ways it's very similar to rounding to the nearest 10. We're just looking at
Oh my
different
gosh,
places.
are we going to do a rounding to the
let's
nearest
say we have the
1,000 as
number
well?
345. And
And
we
then
want to round this
100,000,
to
then
the
a
nearest
million.
100. So pause this video and see. I know I haven't even taught
300.
you how to do that, but what's your intuition? What
Yeah,
is the nearest
intuition.
100 to 345?
Yeah.
Okay, now let's do this together. And what we want to do
Nearest
is first
100?
look at the
Yeah, it's gonna be
hundreds place.
just
And you
300.
can see 345 is 3 hundreds, 4 tens, and 5 ones.
It's between
So
300 and 400.
345, the hundred, the number of hundreds that is right below 345 is 3 hundreds. So it's between 3 hundreds, 0 tens, and 0 ones. And then the number of hundreds that's right above this number is 400. We're in between 300s and 400s. And 400. So if we're going to round this to the nearest hundred, it's going to go to one of these two. Well, to think about which one we round to, we have to think about, well, is 345 closer to 400 or is it closer to 300? And to think about that, we can draw ourselves a number line. And so let me just start my number line
Yo,
here
this is
at-
insane.
I'm starting at 200, so that's 200. Let's make this
The
300.
4
and then
should
this would
round
be
down.
400.
4 is less than 5, right?
And then since let's just see, this would be about 350 right over here, so I'll do the 50s right over there. So that's 350. So where would 345 sit? Well, 345 is a little bit less than 350. It's going to be roughly right over there. So which hundred is it closer to? Are we closer to 300 or are we closer to 400?
300, man.
Well, you
It's
can
like a
visually see
Dora
350
thing.
is right in between. It's 50 away from 300
Is this
and 50
like
away from
Dora the
400.
Explorer?
So 345 is going to be a little bit closer to 300. So in this situation,
Where are we
if we're rounding to
closer?
the nearest 100, we would round down to 300.
Yeah.
Now, another way that you could do this, and it's very similar to what we thought about when we got
God, my back hurts. My neck
we're rounding to the
hurts.
nearest 100. So this is either going to be rounded to a 3 or a 4. And to decide on that,
We're
we
gonna
go to one place value
less than
So to decide on
that.
that, we would go to the tens place. Do this in a different color. Go to the tens place. And in our tens place right over here, if this is less than 5, then we round down. If it is greater than or equal to 5, we round up. So in this situation, it is less than 5, so we round down. If this was 365, well then that would be greater than or equal to 5, so then we would round up. And that makes sense, because 365 would be over here and it would be closer to 400. Let's do another example. We'll do it both with what I just described, and we'll do it with a number line. And I'll actually do a 4-digit number now, just to mix things up a little bit. Let's say we have the number 7,652. Pause this video and see if you can round this number to the nearest 100.
7,700.
All right, now let's do it together. Now we're thinking about the hundreds place. So right over there, you could view this as 7,000s and 600s, or you could even view this as 7,600s. So what are the closest hundreds to this number? Well, this is, you could either view this as 7,600s and 5 tens and 2 ones, or 7,600s, 5 tens and 2 ones. And so either way, the hundreds that are right below this is 7,600s, or 7,600. And the hundreds that are right above this, well, you would just take one more than this 6. So that would be 7,700. 7,700.
I mean,
And
I've kind of tried, right?
Which one would it round to? Well, we could use the technique that I just
Try.
showed you. You go one place value less than the hundreds, which in this case is in the tens position. And you'd say, all right, is this greater than or equal to 5? If it is, we round up. Is this less than 5? Then we round down. This is greater than or equal to 5. It's equal to 5. So in this situation, we round up to 7,700. So in this situation, we round up to 7,700. And we can see that on a number line as well. Let me draw a number line here. And so let me just start at, let's say this is 7,500. This is 7,600 or 7,600. And this right over here is 7,700. 700. And this would be 7,650 right over here. And so 7,652 is going to be a little bit more than that. It's going to be a little bit more. And since you can see it's either right in the middle or to the right of right in the middle, we would round up to 7,700, which is exactly what we just did.
Yeah.
Now let me give you another interesting example. Let's say we wanted to round to the nearest hundred for 982. What would that be? Well, once again, we look at the hundreds place. Well, what's 100 that's right below 982? Well, if you just get rid of the 82, you're just left with 900s. So that would be 900 if you round down. And if you were to round up, what's the hundreds right above this? Well, you could go from 900s to 1000s, and that would be the same thing as 1000. And so I wanted to show this example because when you're rounding up here, the next 100 is 10 hundreds, or 1000. And so we can see very clearly here that if we look at the tens place,
It's 8. It's greater than
8
5.
is greater than or
Yay.
equal to 5. So we are going to round up. So 982 rounded to the nearest hundreds is 1000.
Cool.
Round 24,259 to the nearest hundred.
24,300.
You're going to find that doing these problems are pretty straightforward. But what I want to do is just think about what it means to round to the nearest hundred.
Oh my
I'm going to
gosh.
draw a number line. Let me draw a number line here.
We just
And I'm just
did
going to mark off the
this.
hundreds on the number line. So maybe we have,
We already
let's say
explained
we
this
have
out.
24,000. Let's say this is 24,100. And then we go to
Drilling it into my
200.
brain.
Then we go to
But it's
24,300.
excruciatingly slow and painful.
24,400. And I think
maybe
you see
I'm
what
just
I mean.
tired.
I'm only marking off the hundreds. I'm going up by increments
Yes, I should
of
be
100.
sleeping at this time.
Now, on this number line, where is 24,259?
Right dab in the middle
So if we
between
look at the
2,
number line, it's more than
24,200 and
24,200, and it's less than 24,300. And it's 259. So 59, if this distance right here is 100, 59 is right about there. So that is where our number is. That is 24,259. So when someone asks you to round to the nearest hundred, they're literally saying round to one of these increments of 100, or round to whichever increment of 100 that it is closest to. And if you look at it right like this, if you just eyeball it, you'll actually see that it is closer to 24,300 than it is to 24,200. So when you round it, you round to 24,300. So if you round to the nearest hundred, the answer literally is 24,300. Now that's kind of the conceptual understanding of why it's even called the nearest hundred. The nearest hundred is 24,300. But every time you do a problem like this, you don't have to draw a number line and go through this whole process, although you might want to think about it. An easier process, or maybe a more mechanical process, is you literally look at the number. Let me write
One
it down
place
again.
value less, one place value lower.
259.
If it's
We
less
want to
than
round to
5,
the nearest hundred. So you look at the
or
hundreds
greater than
place.
equal 5.
This is the hundreds place right here. And when we round, that means we don't want any digits. We only want zeros after the hundreds place. So what you do is you look at the place one less than the place you're rounding to. This is the hundreds place. So you look at the 5 right there. And if this number is 5 or greater, if it's 5, 6, 7, it's one less than the place you're rounding after the hundreds place. So what you do is you look at the place one less than the
One less. Sal said left. He did not say anything about left.
place you're rounding to. This is the hundreds place. So you look at the 5 right there. And if this number is 5 or greater, if it's 5, 6, 7, 8, or 9,
Come on.
you round up. So
5 is
5
equal to 5.
or
Let's go.
greater, you round up.
Up.
You round up. And so rounding up, in this situation, it is 5. It is 5 or greater. So rounding up means that we go to 24,000. I'll write the 24,000. And since we're rounding up, we make the 2 into a 3. We increment it by 1. So rounding up, so it's 24,300. 24,300. That's what we mean by rounding up. And just as a kind of a counterexample, if I had 24,249, 24,249, and I wanted to round to the nearest hundred, I would say, okay, I want to round to the nearest hundred. Let me look at the tens place. Let's place one level to the right. It is not 5 or greater, so I will round down. I will round down. And when you round down, be
24,200.
careful. It doesn't mean you decrease this 2. It literally means you just only have the 2. You just get rid of everything after it. So it becomes 24,200. That's the process where you round down. If you round up, it becomes 24,300. And it makes sense. 24,249 is going to be sitting right over here someplace. So it's going to be closer to 24,200. 24,200
Yeah.
would be the nearest hundred when we round down. In this case, for the case of the problem, 24,259, the nearest hundred is
We should have marked the middle
24,300. We round up.
for reference. Okay, cool. Oh, great. Oh my gosh. 4 more videos. Grouping one more, of course. Rounding and regrouping. Okay, cool. Long of recording. Okay, cool. Let's just finish this.
Round 423,275 to the nearest thousand. To the nearest thousand. So let me rewrite it. 423,275.
This is insane. Next video is gonna be 10,000.
So
Come on,
the
intuition,
thousands place
please.
is the 3 right here. And so if we were to round it up, to the nearest thousand, we would go to 420. Let me write it so we just focus on the 3. We would go up to 424,000. If we wanted to round up, 424,000. And if we wanted to round down, if we rounded down, we would go to 423,000. We would get rid of the 275.
This is what I'm
423,000.
doing
So
during
this is our choice.
quarantine.
Round up to 424,000 or
Insane.
round down to 423,000. And to figure it out, we just look at the digit one place to the right of the 3. So we look at the 2 right there. If that digit is 5 or greater, you round up. So this is 5. So if this is greater than or equal to 5 or greater, you round up. If it's less than 5, you round down. 2 is definitely less than 5, so we just round down. So it is 420,000.
You're gonna draw a
Now,
number
just to
or
visualize
line.
what this means, the nearest thousand, if I were to do a number line, and you don't have to do this, we've gotten the answer, but just to have a little bit better visualization of it, if I were to increment by thousands, you might have 422,000, 423,000. You have 424,000. And then maybe over here you have 425,000. And you could keep going. Now, 423,275.
I don't want it.
423,275 is going to be someplace right around here. And so when we round to the nearest thousand, we have to pick between that and that. And we see it is much closer to 423,000 than to 424,000. So we round it right there. We just use the rules we just came up with, and we rounded down to 423,000.
3 more videos.
Let's think about different ways that we can represent the number 675. 675. So the most obvious way is to just look at the different place values. So the 6 is in the hundreds place. It literally represents 600. So that's 600, and then the red color, 600. The 7 is in the tens place. It represents 7 tens, or 70. And then the 5 is in the ones place. It represents 5. So let me copy and paste this, and then think about how we can regroup the value in the different places to represent this in different ways. Copy, and let me paste it, and maybe I'll do it 3 times. So let me do it once, and let me do it one more time. So one thing that we could do is we could regroup from one place to the next. So for example, we could take, if we wanted to, we could take 1 from the hundreds place, taking 1 from the hundreds place will make this a 5. That's essentially taking 100 away. So this is really making this a 500. And we could give that 100 to, or we could actually give it to either place, but let's give it to the tens place. So we're going to give 100. We're going to give 100.
So you turn 170 or
If
17
you give 100
pence.
to the tens place and you already had 70 there, what's it going to be equal to? Well, it's going to be equal to 170. Well, how would we represent that as tens? Well, 170
17 pence.
is 17 tens. So we could just say that 7 becomes 17. Now we could keep doing that. We could regroup some of this value in the tens place to the ones place. So for example, we could give 10 from the tens place and give it to the ones place. Let's do that. So let's take 10 away from here. So that becomes 160. This becomes 16. And let's give that 10 to the ones place. Well, what does the ones place now become? Well, 10 plus 5 is 15. So this 5 is now a 15. Let's do another scenario. Let's do something nutty. Let's take 200 from the hundreds place. Take 200 from the hundreds place. So this is going to be now 4. And this is going to become 400. That's what this 4 now represents. And let's give 100. Let's give 100 to the tens place. And let's give another 100 to the ones place. So notice I'm just regrouping that 200s. Those 200s I've taken from the hundreds place and I'm going to give it to these other places. So now the tens place is going to be 170. We're gonna have 170 here, which is 17 tens. So you could say the tens place is now 17. And now the ones place,
105.
well, I had 5. Now I'm going to add 100 to it.
105
ones.
ones.
It's going to be 105, and 105 ones is literally
105.
And notice, this is 400 plus 17 tens, which is 170 plus 105. You add these together, you're still going to get 675. Let's do that again. So let's take, let's take all of the hundreds away. Let's take all of the hundreds away. So that goes 0. That goes 0. And let's give 400 to the tens place. So let's give 400 to the tens place. Well, that'll make that 470. Do that in that green color.
Okay, someone's knocking. Okay, cool, I'm back.
470, which is the same thing as 47 tens. And then I still have 200 to give to the ones place. Let me do that. So I still have 200 to give to the ones place. And so that's going to go from 5 to 205. 5 to 205. Once again, all I've done is I've regrouped the value in the number 675. Any of these still represent 675. You can add these numbers on the right. They all add up to 675. Fill in the blanks to complete the equation. So they have 76,830 is equal to 6 10,000s plus blank thousands plus 800s plus 3 tens. So let's just think about 76,830. So we write 76,000.
Shit, that's insane.
800.
It's like
and
16,000?
800.
16,000,
We
16,000.
can write this out as being the same thing. This is the same thing as 70,000 plus 6,000. The 7 is in the 10,000s place. So it's 7 10,000s, which is 70,000. Plus the 6 is in the thousands place. So it's 6,000 or 6,000s, one could say. Plus 800, or you could say 800s. 800 plus 3 tens or 30. Plus 3 tens or 30, and then there's a 0 1, so we could just write that out as 0 if we like. Now what we have on the right here is almost what they have on the right over here. Notice the 0, they didn't write that, so we can ignore that. The 0 really doesn't affect the value. We have 3 tens, we have 3 tens. We have, let me do this in a color you can see. You have 800s, you have 800. You have, but then that's where it starts to break down. They have blank thousands. Here we have 6 thousands, so we're going to have to think about this a little bit. And then they have 6 10,000s, which is 60,000. Here there's only we have 70 thousands. So we got to work through these two places right over here. So they have 6 10,000s, which is the same thing as 60,000. We have 70,000. So they essentially took 10,000 from here and regrouped it someplace. And since these two places are the same, they must have regrouped it into the thousands place. So let's try to do that. So let's get rid of 70,000, or let's get rid of 10,000 out of the 70,000. It becomes 60,000. So this becomes a 6. And then we're regrouping that into the thousands place. So we're going to add 10,000 to the thousands place. Now what's the thousands place going to be then? Well, it's 10,000 plus 6,000. It's going to become
16,000.
It's going to become 16,000. This right over here is going to become a 16. So now what we wrote here looks just like what they wrote up here. This is 6 10,000s plus 16,000s plus 8 hundreds plus 3 tens.
And we're done.
We're done.
Yeah.
Fill in the table with whole numbers.
Minute.
430 in 5 different ways. So let's think about this.
5 different ways.
We
Holy
could literally
shit.
view this 4 as 4 hundreds. So it's 4 hundreds. And the 3 is in the tens place, so it's 3 tens. There's 4 hundreds and 3 tens. But we could rearrange things a little bit. For example, we might only have 3 hundreds. So we took 100 from the hundreds place, and we could give it to the tens place. So if you take that 100 and give it to the tens place, 100 is 10 tens. So you got 10 tens, and then you already had 3 tens, so you're going to have 13 tens. 13 tens right over here. Now if this seems a little confusing, remember, this is 430. This is 300 plus 130. That's still 430. Likewise, you could view this as 200 plus 230. 230 is the same thing as 23 tens. Same way, you could view this as 100 plus 330. 33 tens is 330. And finally, you could view it as 0 hundreds and 43 tens. 43 tens is 430.
One, 6, 2, 7, 1, 90, right? 1, 2, 3, 4, 5, 6, 7. Nearest that. Okay. Eric tried to evaluate this step by step. Find Eric's mistake. 2, 7. Yo, step 1's already wrong. Should be 1,000, man. Select the statement that explains the relationship between 90 and 9. 90 is 10 times, no, it's 10 times as much as 9. It's 10 times. Use the place value chart to write 60,000. Okay, we have 6,000 and 0,000, so we have 2. Cool. 470 is 400s plus 7 tenths, which is another way to make 470. Okay. Definitely this one. Why is 700s down? Okay. Use the place voucher to write 4,607. No tens. 4,607. Cool. No change, not tested, 1 skill. Okay, I guess I'm going to end the video here. Yeah, I'm going to finish it tomorrow. The rest of this thing. It's gonna be a lot of video watching and I'm getting real sleepy. My eyes are giving up on me already. So yeah. Tomorrow I'm gonna finish this section, arithmetic properties and pre-algebra. So yeah, let's see our notifications. Yep, okay. From 4 to 2, how much should we eat? How much did we earn? It became seriously 1%. Okay, it's pretty insane. Still 18% on the world of math. It's pretty funny. Okay. It's probably because I didn't really do any mastery with these skills, just video watching mostly this session. Yeah, okay, so that's it for this part. And I believe, yeah, alright, goodbye.